Hi guys, to understand the upcoming concepts like measurements, I would like to give or I would like to recall whatever the previous knowledge we are having. So that is necessary to me. First one, that scientific notation. So we used to mention each and every quantity in terms of scientific notation, or nothing but it's an order of power of 10. Suppose if you want to write 25 kilometer, so this we can mention just like 25. It's nothing to mention more than that in terms of kilometers. But I want to convert this in terms of meters. So the same quantity we can mention that in terms of meter 25 times kilometer I can write in terms of 1000 meters. So usually we used to mention that 25,000 meters. But in the scientific notation, we won't mention that much big numbers. So instead of writing like this, what we used to write? So we used to write this 1000 in terms of 10 powers. So if you can write the 1000 in terms of 10 powers, that becomes 10 power 3. So the 25 kilometers we can write in the scientific notation or the power of 10, 25 times 10 power 3 meters. How simple it is. So this is only we are calling as an order of powers of 10. Suppose you take one more example. So that is, suppose if you divide, you are having a division. So let that division is 2 by 1000. So if it is a 2 by 1000, so in terms of scientific notation, how to mention that? So we can write that 2 by 1000, we can mention that 10 power 3. So this 10 power 3 you can take to the numerator side, and that will become as 2 times 10 power minus 3. So this we call as scientific notation. Okay. Now just recall, and each one is having certain name. Suppose if you remember that the chart which I can show at here, yeah. Suppose if it is the 10 power minus 3, so that we supposed to call millimeter. Milli, not meters, it's milli. And if it is the order of 10 power minus 2, we call it as centi. And if it is the order of 10 power minus 1, that we call it as deci. It means, suppose if you are writing as in 2 mm, an object diameter 2 mm. So 2 mm means stands for 2 millimeter. So in terms of ordinary notation, how we can convert milli in terms of, so that we have to write it as 2 times 10 power minus 3 meter. That it means. So we are representing that in terms of this kind of notation, which is known as order of power of tens or scientific notation. Now if you can take the numbers, means if the order value goes to minus, increases, it means the size will be decreases. And we know that if the number with negative sign minus 9 is greater than minus 12. So minus 9 is greater than minus 12 because minus 12 is the smallest quantity in this case. So each value is having its own pronouns name. So if it is an order of 10 power minus 6, we are supposed to call micro. So we are representing that with a symbol of mu. And 10 power 9 is called as nano n, and 10 power minus 12 called as pico p. And above the order 10 power 15 femto, and 10 power 18 atto, 10 power 21 zepto, 10 power minus 24 octo. So in between we need very important at here. So that is the order of 10 power minus 10 that we can call as angstrom. 1 angstrom equal to 10 power minus 10 meters. So that in terms of meters we can call. So 10 power minus 10 meters equal to 1 angstrom. So the order of the negative signs, so what here representing that, so they are having certain names. So when any problem, suppose if the problem is given that the bacteria having size of 32 microcentimeter or micrometer. So 32 micrometer means how do you can write, that is you can write as 32 times micro 10 power minus 6 meter. So that's the way to represent. So try to remember at least the darker ones in this ones, 10 power minus 3 or 10 power minus 6, 10 power minus 9, yeah, up to 10 power minus 12 it is sufficient. 10 power minus 15 also femto. So likely if it is a negative sign, we used to represent in the order of 10 power minus 2. So similarly if it is a positive sign, suppose if you are driving a 2 kilometers. Now try to mention the 2 kilometers in terms of meters. So you can write that 2 times 1 kilometer goes to 1000 meter, which is equal to 2000 meter. So in the scientific notation we represent that 2 times 10 power 3 meters. So the kilo we are representing in terms of 10 power 3 meter. So in a simple manner I can write 1 kilometer equal to 10 power 3 meters. Or similarly 1 meter equal to 10 power 2 centimeter, 100 centimeter. 1 meter contains how many centimeter? It's 100. 100 we can write as 10 power minus 2. So it's having the positive powers. So kilometer having the positive power 10 power 3, meters having a positive power 10 power 2. So likely the higher, suppose what we can call 10 power 6 or 10 power 9 or 10 power 12. So this terminology we already know it. If you are familiar with computer memory and all, 10 power 6 we are calling that as megabytes, or this one here itself also you can remember. 10 power 3 we can calling as in kilo. In the computer terminology you can call as computer bytes, kilobyte, it says megabyte, and this goes to gigabyte. And 10 power 12 you can that take as terabyte. So the positive signs and the negative signs, if we can prefix that, now from 10 power 1 deca, and 10 power 2 hecto, 10 power 3 kilo, 10 power 6 we call as mega, 10 power 9 giga, 10 power 12 tera, 10 power 15 peta, and above that 10 power 18 we call as hexa, 10 power 21 zeta, and 10 power 22 yotto. So that is the positive terminology. So as like the same we are having the negative terminology. 10 power minus 1 deci, 10 power minus 2 centi, 10 power minus 3 milli, 10 power minus 6 micro, 10 power minus 9 nano, 10 power minus 12 pico, 10 power minus 15 femto, after minus 18 atto, minus 21 zepto, minus 24 yocto. So these are the scientific notation or powers of 10 we are going to use in the upcoming. So the prefixes, they are the in terms of that. It means if you can write that, they are having certain meaning. So this we already used. Suppose a resistance R equal to 60 mega ohm. So if it's 60 mega ohm means I think about how much you have to take? We have to take in terms of 10 power 6 ohms. So that's the thing I will need to remind. So the second thing I want to remind you that is very important, that the largest distance measuring unit. So what is the largest distance measuring unit? I hope you will know about light year. 1 light year. So it is a distance measuring unit. You know that kilometers are the distance measuring unit. But above that, there are two more measuring units are there to measure the distance. So among that, first one is the 1 light year. What usually this difference says? The distance traveled by light in 1 year. According to definition, the distance traveled by light in 1 year is called 1 light year. So 1 light year, who is traveling? Light is traveling. So what is the speed of light? On roughly I can take that speed of light in terms of 10 power 8 meter per second in 1 year. So 3 times 10 power 8 meter per second. 1 year we are converted to 365.25 days. Now again we will convert that days into 310 power 8 meter per second times 365.25 day. 1 day contains 24 hours and 1 hour contains 60 minutes and 60 minutes contains 60 seconds. Now the seconds gets cancelled and we will get the final result in terms of meters. So 1 light year is the distance traveled by light in 1 year. So if I can take that number is giving the order of 9.467 times 10 power 15 meter. So this we define as 1 light year. So the distance traveled by light into these many meters, the distance traveled by light into these many meters, 9.467 times 10 power 5 meters is known as 1 light year. So 1 light year is the distance measuring unit. So apart of this one, we are going to use one more unit, that is also distance measuring unit, that is known as 1 astronomical unit. One astronomical unit means nothing but the distance between the earth to sun. So it's defined as the mean distance. The mean distance between earth to sun. the mean distance between the earth to sun, that is also we are taking as one astronomical unit. Also if we can take that as equal to 1 AU. So this is also large measuring unit for distance. So we will use that one astronomical unit. It's already having a value, since we know the distance between earth to sun, that is 1.496 times 10 power 11 meters. So this is the distance between the earth to sun. So that also we are taking one of the distance measuring unit for the large range. So apart of this, you already know that one more unit, one nautical miles. So that is also you try to get the what is the one nautical mile, one nautical miles in terms of the kilometers. So you know that 1 kilometer. If you can give 1 kilometer equal to dash nautical miles. First of all, here mile is the one more distance measuring unit instead of the kilometers. So all the British units they used to measure in terms of the miles. So I can give that value 1 mile equal to 1.069 kilometer. So this is the British measuring unit in terms of the miles. Whenever you can watch kilometers, they used to say miles per hour. But if you can convert 1 mile equal to 1.609 kilometers. Similarly, here I can give the value of 1 nautical mile. 1 nautical mile. 1 nautical mile equal to 1.852 kilometers. So these nautical miles are the usually used to calculate the distance traveled in the water especially. So that is the on the road we don't use nautical miles and all, but when we travel in the sea, so the ship traveling in the sea, so they used to measure the distance in terms of nautical miles. So in the space, in the air also they used to measure in terms of the nautical miles. So here I discussed about that lower units of the powers of tens in terms of 10 power minus 2 and 10 power minus 6 and 10 power minus 8. Likely higher units 10 power 6 and 10 power 9. A part of that, light year, the distance traveled by light in 1 year. So that is also large distance measuring unit. And one more thing is the astronomical unit, that is defined as the distance between earth to sun. That gives us 1.496 times 10 power 11 meters. And apart of this, when we measure angles, so there we need to concentrate little more. Suppose we know that angles, according to if we can draw at here, I would like to take the coordinate system at here, so that okay. Now if we can draw the angle between at here, so this angle we already know that 90 degree. So if we can cut this into small portions, and this angle will becomes as 45 degree. The angle made, this is the one, 45 degree. Like that again, if I can cut, I will reach a least angle of 1 degree. So 1 degree means nothing but the smallest angle we can measure by using protractor. If you are having protractor, take the protractor and ask yourself, What is the least angle I can measure by using this protractor? How much it is? It is a 1 degree. Or if you ask a question, what shall I do if I want to measure smaller than 1 degree? So it's very hard to show at here 1 degree as an angle, but I would like to show it's a 1 degree means a very small angle I can get it. Very small means very small. Suppose this angle, if I take that as a 1 degree, so this portion I am taking as 1 degree. So I want to know that what is the smallest portion of that. So for that, to measure angles, smaller angles, so we are using as another system of methods, so that we can mention as degrees and minutes and seconds. So this is the angular methods, means angle small units used to measure. So according to this standard definition, so we are having certain standard definition. According to that standard definition, if you can take that 1 arc minute or 1 minute is the unit of angular measurement, which equal to 1 by 60th of 1 degree. Don't be confused at all. If I can mention from this definition 1 arc minute, so if you can write from this 1 degree equal to 60 minutes. So these are the symbols we are using for minutes. Okay, now from this we can write the definition for 1 minute. So 1 minute equal to 1 degree upon 60. So here 1 degree only we are measuring as an angular measurement. Angle, it's a degree is an angle. Angle measurement. So here the 1 arc minute. Minute here, this is the 1 arc minute. This 1 arc minute is the angular measurement equal to 1/60th of degree. Yeah, this is the 1/60th part of the degree. So the lower unit of degree, we can take that lower unit of degree as minutes. So that's why these are the degrees and minutes and seconds. So lower units to the degrees to minutes and lower units to the minutes goes to seconds. My dear students, here don't be confused with the clock. Don't at all confuse with clock. If you are remembering, clock is also having minutes and you are trying to convert that minutes into in terms of the degrees, so that leads to a huge confusion. So when you are remembering these degrees, minutes and seconds, so these are the another measuring to measure the angles. So the least angle we can measure by using the protractor is only 1 degree. So below that angle we want to measure. So I can write simply, so 1 degree equal to 60 minutes. And here I am writing one more unit. So 1 minute equal to 60 seconds. Yeah, second one is already matching to our known knowledge. That is the time knowledge, not the angle. So here angles also used to measure in terms of the degrees. Yeah, that knowledge we know it. But the lower than that, the smaller than the degrees, we are measuring in terms of minutes. And the smaller than that, we are measuring in terms of seconds. Okay. If you want to give as an analogy, suppose if you take that 1 degree equal to as degrees, I should not write 1 degree equal to, if you take analogy in terms of degrees, it's an angle which equal to something like kilometers. So these are in terms of meters. And the lower than the degrees, what you are using? Minute. Minute is something like that, meters. And lower than the minute, what you are using? We are using as in seconds. So here it is something like that, meters lower units goes to centimeters. So how meters are the lower than the kilometers and how centimeters are the lower than the meters? Likely, so these minutes are the lower than the degrees and the seconds are the lower than the minutes. So this knowledge we will use for the upcoming whilst measuring methods concept. In the next part, I would like to discuss how to measure. We are going to measure length, small to big. We are going to measure masses, small to big. We are going to measure time, small to big. And we are following certain methods. So to understand those methods, and this concept is very helpful.